Hello everyone, I'm audible to all of you?
Yes, sir.
Okay, so good. Today I'm going to share my view on the topic of modeling of EV motor and discuss different types of motor, mathematical equation and charging technique. So we are going to start the session now. Here we have classified the motor according to power supply. The motor which runs on the DC power supply, we said DC motors, where like DC shunt motor, DC series motor, compound motor, which is used for the initial high torque and which is used for the running initial high torque, where we are using, and the motor which we are using on the AC power supply, we said that AC motors, like a asynchronous motor or synchronous motor, which is having a synchronous motor which runs on the fixed speed, whereas an induction motor which works on the basis of induction principle. And we also categorize, along with this, we also categorize special motors. The motor which perform the special purpose, like said, a special motor which comes with a less disadvantages and a special technique. We will go and see this BLDC universal types of motors and along all the special techniques in upcoming slides. So servo motors are basically used for the angular precise angle displacement. Stepper motors are using for the laser cutting, 3D printing. Universal motor is a kind of special technique which is work on AC power supply as well as DC power supply also. BLDC motor which having a special function, that is work on the DC power supply without the brushes, as well as it works on the basis on the response of Hall effect sensor. So we are going to see all this. As we are using DC motor and providing power supply to rotor as well as stator also, where in AC motor we are providing power supply only to the stator. We are not providing power supply to rotor, where in some of the AC motors we are providing a rotor also power supply for the initial thrust only. But we have seen a lot of drawbacks regarding the brushless motors, regarding the brushless motor, like periodic maintenance required, not supporting a high power density, less efficient, poor heat dissipations, and many more. So we have classified that motors as a brush motor and as a brushless motor for the better choice of EVs, like wound rotor and DC motors like series shunt motors are which are having a brushes, and the brushless motors like a synchronous reluctance motor, which is work basis on the salient and non-salient poles. Switch reluctance at the time one electromagnetic coil is energized, which will create a magnetization effect, and according to that rotation work. BLDC motor, again the brushes are not there. Permanent synchronous motor, which is a combination of BLDC motor as well as AC motor also. So we will see several types of motor. So for basic understanding, we have to understand the working of motor, we have to keep our foot back and look for some basic laws of the motor. So we will start with the Faraday's
Reshare your screen. Please reshare your screen.
Isn't visible?
Visible, sir.
Stop sharing and then start your screen, okay?
Okay, now my screen is visible to all of you.
Yes, sir. Now it's visible.
Yes, sir. It is visible.
Okay, sorry for the interruptions. And okay, I will restart it from the classification part of the motors. Here we have classified the motor according to the power supplies. The motor which runs on the DC power source, we called as a DC motors, like a shunt motor, series motor, compound motors, which is used for the initially high torque or a running initial torque. And we are going toward the AC motors. The motor which runs on the AC power supply, we said as a AC motor, and they are in two types: asynchronous or synchronous motor. Synchronous motor which will provide a fixed speed, where induction motors which are having a variation in the speed also, or it works on the basis of the induction process, where we have also categorized that a special motor. A special motor is designed for the special functions or special purposes, which comes with the less advantages and the special techniques, like a servo motor, which is used for the precise angle of movement, like a robotic arm, and stepper motor, which is used for the sequence order or for the laser cuttings, 3D modeling. A universal motor having a special technique, like its work on the AC as well as DC motor also. And one of the motors is a BLDC motor, the motor which is having a DC configurations, and but it will not providing power supply to rotor, and it works like same as a synchronous motor, and it's work on the response of the Hall effect sensor which is present on the motor. It will not work without the controller. So that type of special technique, we'll see this in the upcoming slides. As we are using DC motor, we are providing a power supply to stator as well as rotor also. Where in AC, we are providing power supply only to the stator. We are not providing power supply to the rotor part in asynchronous motor. Where in asynchronous motor and some of the synchronous motor, we are providing power supply to rotor part also for the initial thrust. But we have seen a lot of drawbacks in the brushless motor, that periodically maintenance, not supporting a high power density, less efficient, poor heat dissipations, and many more. So we have classified them brushless motor and brushless motor for the better choice of EV selections. So we at the part of brushes, we have kept that wound rotor, asynchronous motor, DC motors. Like at the DC motors, all the series motor, shunt motor, compound motor comes. Where it come about the brushless motor is a synchronous reluctance motor. Synchronous reluctance motor, which works on the basis of salient and non-salient poles, and switch reluctance motor, where the at a time two poles are energized, which will create a moment of rotation, and which will only create a poles of north and south pole at a time. Where the BLDC motor having a configuration that it will work only basis of the response of Hall effect sensor, but the brushes are not there. So it will increase the efficiency, and the lifespan of motor is also increasing. Permanent magnet synchronous motor, here we will see that AC power supply is a combination type of motor, where a induction motor and BLDC motor. As well as we will see that squirrel cage motor, we are not providing power supply to the rotor part, and reluctance motor. So we will see all this type of motor. But to understand the working of motor, we have to keep our foot back and look for the basic laws of the motor. So we are starting from the basic, and we are going towards your childhood life. That Faraday first law. What's the Faraday first law? State that whenever a current carrying conductor is placed in the variable magnetic field, it will induce electromagnetic force. Whenever a current carrying conductor is placed in the variable magnetic field, means a magnetic field is always in a variation or maybe in a movement. At that time, EMF is induced in the coils. And second part of law is said that induced EMF is directly proportional to the rate of change of magnetic flux, which means to say that the EMF is generated is depend upon the number of coils. Number of coils, if the number of coils are more, then the EMF is increasing, because they are directly proportional to each other. Along with this, we have also to look the basic laws of Fleming left-hand rule and right-hand rule. Fleming left-hand rules are used for the electric motor, where Fleming right-hand rules are using to determine for the generator part, where we are focusing more in the Fleming left-hand rule. It has helped us to determine the direction of force acting on the current and carrying conductor placed in the magnetic field. So it is we will easily identify that where was the movement of passes through the electric current carrying conductor pass, where you can see that in here two permanent magnets are connected and the brushes are connected to them, and these are the commutator. According to that, the polarities are changed and commutators are play a role of to interchange the polarity, or we can say that the commutators are used to convert DC power to AC power source for the magnetic polarities. So we start with the brushes DC motor. Here is a one animation part is also there. In a brushes DC motor, we are providing a power supply to stator as well as rotor part also. You can see that how the commutators are connected and interchange the polarity as a positive and negative according to the poles are changes, where the red color denotes about the north pole and south colors depend upon the south pole. I hope you will all know about the basic law of magnetism, that same poles are repel and opposite poles are attracted. According to that, the movement of rotation was working in this motor. And this is a permanent magnet DC motor, which you can see in small appliances like a toy car and many accessories which are available in your hand also, like trimmer and many of the clocks, etc. But you can see that the major part was facing we are through the brushes, because according to time, the carbons are created in the brushes which can decrease the lifespan of the battery. And we can't provide a external power supply for the armature winding at the time of movement. So we'll come with the brushless DC motor. Here you can see that brushless DC motor animation part and BLDC work motor. The basic part, the power configuration is supplied through the inverter connections. In the inverter connection, where the switching pass is connected to the transistor, and I will also I will show you the controller configuration part also. BLDC motor works on the power source of DC power supply, which we'll call as a direct current, and these are having a permanent magnets in the rotor. So we don't provide a power supply through the commutator and along with this, and make the use of Hall effect sensor to identify the rotor position and operations. According to the response of Hall effect sensor, it will give a response to the controller that which one for the which phase we have to give a power supply. As you all know that in DCs, there are no single phase or three phase connection. So how the motor will work? That was a biggest cause or biggest questions or challenges was faced by a lot of students, that how if the DC motor is having a single phase supply, then how three-phase wire BLDC motor is working. So we will see and clear our concept in this. So this was a BLDC normal motor which is having a 12 kilowatt power, and you can see that I will show you where the Hall effect sensor. This white one was the Hall effect sensor, and which will detect the position of rotor, and there are having a 5 wires for the sensing part, and which work on the power supply of 5 watt. And along with this, all 3 wires are connected for the creating a poles for the stator part, and at a center is a north pole. This one was a south pole. It is not easily identified. We have done that several tests, and this was taken by the picture of by me only. So we will easily identify that I already marked that which one was a north pole and which was a south pole. So that's why I'm easily identified to say that which one was north pole or south pole. But it is not easily, while seeing, you can't able to say that which one was a north pole or which one was a south pole. So I will show you the controller response. Here we are giving a DC power supply for let's take an example for a two-wheeler. We are giving a power supply to 48 volt to 72 volt for an operating voltage range of DC current. And according to the switching provided through the transistors, MOSFETs, power supplies are given to the motor. And it's take a response through the black wire and red wires are connected to the controller to providing a power supply to the Hall effect sensor, and blue, yellow, and green, a thin wire are taking a response back through the Hall effect sensor, according to that only the power is delivered to the motor. So this, according to that only, if we disconnect the Hall effect sensor wire, or if we don't provide a power supply direct to the BLDC motor without the controller, it can't work, because the magnetic field or 360-degree or 120 phase degree is not generated in the motor field. So I will show you that according to that only, the one simultaneously at a time, two poles are powered and one powers are switched off. And you can also see that the direction of current is also different. Like that only, the north pole and south pole at a time interchange. There is a north pole and now it's a south pole. Simultaneously, after one slot come, it changed that it's created a south pole and it's created a north pole. So simultaneously, it's will changing according to the response of Hall effect sensor only, which is present in the motor only. Like that also, we are having a hub motor, which is also a part of BLDC motor. But the major difference between hub motor and normal BLDC motor, that the stator part and rotor part. In the BLDC motor, the rotor part was the mid of the motor, where in hub motor, the rotor part was the exterior part, and the stator part was the interior part of the motor. And it is in the form of radial flux flow meter. The radial flux flow meter, where the flux passes through the radial form, where in axial flow meter, the flux was created, magnetic flux was created through the...
Hello, sir.
Hello, yes?
The screen is not visible.
Hello.
It is visible, sir.
Hello.
Visible, sir.
Visible, sir. It is visible. It is visible.
Not visible.
Just reshare your screen.
Audible.
Yes, please reshare your screen.
Visible, sir.
Sir, someone are saying that is visible and some are not saying not visible, sir.
Not visible, sir.
Okay.
Kindly reshare your screen, sir.
Reshare.
Okay.
Not visible, sir.
I'm resharing my screens. Now it's visible to all of you.
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir. It's visible now.
Okay. So here we are for that hub motor. So these hub motors are basically used for the two-wheeler only, or for the project purpose, and for the electric bicycles also. Here it's work on the basis of rotor side, where the rotor part is the exterior part and the stator part was the interior. It's a vice versa of normal BLDC motor, and the efficiency is very low as compared to BLDC motor, but still it's providing a synchronous speed. At very less speed, we are using we are getting at a two-wheeler, we are getting 45 kilometer as a speed range of this. And this is following radial flux flow motor, where the radiations of flux flow through the radial form, not in the perpendicular form, where the axial flow meters are used for the three-wheeler or for the powertrain configuration. So this was the circuit configurations, which we are going to see here, how the configurations are given to the stator part, which was at center part of the motor. So you can see the animation part also, how the polarities are changing in the stator part, and the rotor magnets are fixed. According to the polarity interchange, the movements are there in the outer side of the motor. It is very easily to install in the tire, or we can say as a wheel of the two-wheeler. So it is preferable more for the two-wheeler side. So we will move toward the induction motor. From its name, it's called an induction process, or basically we are providing power supply to the stator part. We are not providing power supply to the rotor part. basically we are having a squirrel cage where the wound conductor bars are there. According to the magnetic field is creating on that. What was the pop-up message was coming? Okay, I continue. So we are in the induction motor part. In the induction motor, the initial torque is not too much good, where we are providing a power supply to the stator part only. We are not providing power supply to the rotor part. It simultaneously draw a magnetic flux in the rotor part, where we are basically using the squirrel cage for the every appliances, like in necessary fans or home appliances, where induction motor is this work on the principles of magnetic inductions, and this motor having a low starting torque. And the rotor consists of the aluminum and copper bar for the heat generation of the rotor and high need of magnetite. So here always be a maintenance should be required, and the lifespan of induction motor is minimum 3 to 4 years. Without repairment, you can't use this for a long time. So we'll move toward the electric induction motor having a two types. Or we can, induction motors is also called as a asynchronous motor, where a squirrel cage motor and a slip ring motor. In the squirrel cage motor, we are not providing a power supply, but in the slip ring motor, to rectify the drawback of high initial torque, we are providing a star connection resistance power supply to the slip ring at a center part. And it can initially initially clear the drawback of the squirrel cage, and it is basically used for the industrial purpose only. We are moving towards the synchronous motor. In the synchronous motor, we are seeing that we are providing a power supply to stator as well as rotor also. We are providing power supply, AC power supply to stator, and we are providing DC power supply to field winding to create a rotation magnetic field and for the initial thrust. And after the creating of rotation magnetic field, it was interlocked with the magnetic field. After the interlock of magnetic field, you can cut the supply of DC power supply, and you can easily go through that. And it's also depend upon the poles. We will calculate the various speed, which is 120 F by P. According to that, you will get a synchronous speed at a minimum number of poles. At a minimum number of poles, it's the maximum speed be at 3000 RPM. So we'll move toward the permanent magnet synchronous motor, which is a preferable choice for the electric vehicle, and the IMP synchronous motor also there are the internal permanent magnet synchronous reluctance motor, where the architecturing of this motors is very much conflicts, or we have seen a very much lot of conflicts in this architecturing part. Permanent synchronous motor or AC motor consists of permanent magnets. It combines best of the word induction motors as well as the BLDC motor also. They generate less rotor heat and high efficient. This motor generates a high initial torque as compared to BLDC motor and have a more gradual torque curve, which through the white operation range. So it will provide a initial high torque also, and at the time of running also, whatever the acceleration, sudden acceleration, it will cover up with this. So we are preferring this for nowadays in the Nexon EV Max also. We are having different lot of the motors. We are having different kinds of lot of motor according to the appliances, according to the speed requirement and the torque curve situations. Characteristics of motor, we will select the motors. Basically in the EVs field, or you can see that in electric vehicle, we are using induction motor, permanent magnet synchronous motor, maximum time, and IPMS motor, which is internal permanent magnet synchronous reluctance motor for the higher torque and to overcome of the sum of drawbacks which are facing. But these are all the motors which are using for the four-wheeler, where for a two-wheeler and three-wheeler is a preferable choice for the two-wheeler and three-wheeler is BLDC or hub motor only. So we will start with the mathematical modeling of the DC motors. The mathematical modeling of DC motor consists of, so at the part of derivation, firstly I have to introduce all the components which are connected to the DC motor. Okay, so represent, here we can see that, okay, starting with this, here's the pen. Represent the inductance and resistance coils of the motor, where L R are the representing the inductance of coil of the motor, where V in providing an input power supply. Motor will generate a back EMF, which is denoted with the epsilon, and motor is also connected with the shaft for the rotation part, which having create a moment of inertia, and we will identify as a J. Rotated magnetic speed is omega, and the produced torque is called tau. So after denoting all this part, we are starting with the basic laws of KVL, voltage law. All the sums of the voltage across the closed loop of circuit is equal to 0. So basically V in minus VIR, V in minus VR minus VL and minus epsilon is a closed loop circuit, and the sum of is equal to 0. When we are looking for the current flow, we will see that where I is passing through here. So we will see that VIN minus IR basis on the Ohm's law, and for the inductance process formula, and we will get epsilon law formula from here. According to that, we will get a systematic equation for the current flow. But we also know that the motor torque is proportional to the armature current. Motor torque is proportional to armature current means T is directly proportional to I, where I can also write is T is equal to Ki. K is denoting a constant, motor constant, where if power conservation across this motor, T is product of T and the angular velocity is equal to epsilon and I, where Ki is a constant current of motor, and the angular velocity is equal to epsilon and current, where if we cancelling from current from LHS and RHS both of side, we will get that epsilon is equal to constant of motor and angular velocity. So it states that epsilon is equal to K omega. So it will help to electrical and mechanical students basically to clear the systematic equations for rotation of the shaft and conservation of angular momentum. So at that sum of the rotation, we identify that torque is equal to moment of inertia into angular of velocity, where T is denoting, where the T is the part of hello, whose pop-up is coming?
Jayesh, you can ignore this. It is like the pop-up for the new participants.
Okay, sir, simultaneously these pop-ups are coming, sir.
Okay, okay. No, don't worry. Like you are the co-host, that's why they are giving the pop-up notification. Okay.
Oh, okay, sir. No problem.
Okay.
So we will move towards the when we'll take a tau is equal to moment of inertia and angular velocity. If we place as per the equation that tau t is directly proportional to I, so we can write that constant of motor and current is equal to joule per j and omega j omega. Where applying a equation number 2, we will substitute that I is equal to jk omega, and when we substituting this formula into equation number 2 and 1, we will get that jr is equal to k for the resistance part, jl k for the inductance part, and k omega for the epsilon part, where is equal to applied voltage. So this will give a second order differential equation with a constant coefficient, which can help us to design a graph for the torque saturations part also, or in most of the case, inductors has very low impedance as compared to resistance of the coil. So we will, for the assuming that inductance is negligible, so we are if the inductance part is negligible, then we are coming with a VIN minus IR minus epsilon is equal to 0. So when we are substituting that formula, we are placing epsilon is equal to K omega, and for the IR, we are placing T by KR. So we will getting a torque equation formula. So when we are putting all the three equations, equation number 2, simultaneously this one, and at a back time of the basic law, which is a current is directly proportional to torque, we will identify that we will get this equation. T is equal to applied voltage minus constant motor omega into constant of resistance. So it is easy to explain, and we will get the expression for the generating a torque speed curve. And torque speed curve which help to represent the characteristic of motor performance, and as per that we will see that torque and the speed of motor, along that we have a different type of characteristic, and the current and voltage parameters is directly proportional or inversely proportional. So as per that also we are selecting the motors in the field of electrical part, where we'll come toward the mechanical part. Three basic things which are providing an important role to select the motors, where aerodynamic force act a very important role, gradient resistance and rolling resistance. So first of all, I start with the aerodynamic force. The aerodynamic force, this resistance force act on the vehicle body due to motion of the air. And there are two basic force are act on this, is drag force and lift force. Drag force is the opposite force which act the movement of the vehicle, whereas lift force is the perpendicular force applied toward the upside of the vehicle. Where rolling resistance point, the rolling resistance opposes the force acting on the contact patches of the tire, and when a vehicle moves from one place to another place. Where gradient resistance, the opposes force acting on the vehicle when it drive on a slope or a gradient, or we can say that the angle of surface on which is drive on, or it's depend upon the coefficient of friction. Basically, when we are climbing up or we are sloping down some of part, what are the angle of highly acceleration, which is decided by the gradient resistance. Like the maximum gradient resistance should be a 45 degree, where in India and for normal conventional vehicle, the gradient resistance should be a degree of 15 degree to 20 degree only. Along with mechanical and electrical part, some major factors, several factors are play an important role in the selection of motor for the EV. Power requirement, efficiency level is very create an important role to prefer any motor for any of the work. Where size and weight, yes, it's it depend upon the design of vehicle. Like we are preferring for the 2-wheeler, 3-wheeler, or we are preferring for the 4-wheeler or 18-wheeler or 6-wheeler like a high dumper truck. So according to that, we are preferring or we will select the motor for their performance and their characteristics, where cost is creating also a major part. Like we are moving toward the innovation, but simultaneously we have to reduce the cost of the appliances all, because the future scopes are moving towards the development without the wastage. So according to the manufacturing, their cost level are too complex and the costing is very high. We have to also think that it should be suitable for a middle class family or a standard family. So according to that, we have to select the motor and we have to keep the price according to that. And we also looked at the controller feedback controller circuit, or the motor which work on the AC driver or DC driver. What was the configuration and what was the controller efficiency, controller systems is work on that. It's also depend upon that also. So we will cover about the BLDC motor, induction motor, and permanent magnet synchronous motor. But we will see that there is a lot of difference between all of these three. There is a maximum difference of this efficiencies motor are average 90s, 95, 90, 98. But the minimum part, we are getting a very low efficiency from the BLDC motor. Whereas in the minimum performance also, permanent magnet synchronous motor is giving a good efficiency. Where in come to the weight category also, permanent magnet synchronous motor as compared to induction motor is having a very good size is simultaneously same, where as per the induction motor, heat dissipations are more. So the size was exactly very much high and complex for the induction motor. Cost is minimum cost as compared to the BLDC, because BLDC without work for the Hall effect sensor, or it don't work depend upon the controller. So we have a lot of things, then only we can use the BLDC motor, where the permanent synchronous motor work on the AC power supply. So we can use simultaneously and we don't have to provide any external equipment, and which will increase our cost of the motor. Where appliances, at the part of appliances choose, BLDC we are preferring for the 2-wheeler, 3-wheeler. Now you can see as a e-rickshaws and for the scooties is launched by day by the many of the branded companies, like induction motors for the truck and for the hybrid vehicles also. At a time of best part, Tesla was launched in 2016 only, the first induction motor based vehicle, or in 2002 it was delivered by the Roadster, where permanent magnet synchronous motor moving towards the passenger car, buses, and it will coming nowadays. You can see the Nexon EV Max, which is also having a permanent synchronous motor and which is having a high efficient, and it having a battery pack of power storage of capacity of 30.2 kilowatt hour. So that's a lot of energy was stored by the Nexon EV car only, which are nowadays you can see in the road also. So we are moving towards take one of the two or example, and then we will move toward the charging techniques. What are the charging techniques we are seeing in lot of days, or you can see also that the charging stations are available at your surrounding. And you can see also that what was the charging capacity. This was a level 1 or level 2. According to that, we will see. These are the 3 branded companies which are having a high 5-star ratings in market, like Ather 450X, TVS iQube, and Bajaj Chetak. Which in all of this scooty, you have seen that hub-mounted BLDC motors are used, which is directly installed in the wheels itself, and they are providing a mileage of a 70 kilometer. Okay. So we will come towards the EV charging technique. So basically, EV charging techniques are classified into two types: onboard charging station and offboard charging station. Where onboard charging station is also known as a level 1 and level 2 charging station, and offboard charging stations are level 3 charging station. Basically, in the both charging station, we are providing AC power supply. In the onboard charging station, we are providing AC power supply to the vehicle, and it convert AC into DC, where the onboard charger is connected in the vehicle, and then it providing DC power supply to charge the battery. Where in offboard charging station, we are providing AC power supply to the charging station. Power station itself convert in the charging station point only, and it can deliver direct DC power supply to the battery. That's why it's called also as a fast charging system. Along with this, these two are present in the market. Along with this, a research part is still going on the wireless EV charging technology also. In wireless EV charging technology, there are two types, again, a static and dynamic charging, where you have to just go and keep your vehicle in initial condition. You don't have to move your vehicle, and you will get easily your, without connecting any plugs, you can easily charge your vehicle. Whereas in dynamic charging, you can see that one side lane was in the highways. You have to just go to cover the 10 kilometers, which will cover up the drawback that electric vehicle having a limited drive range. So that's why it was created a side lane in the highways, and as per that you will cover a 2 to 3 kilometer in that lane. Your vehicle is automatically start and support the fast charging. But the research part is still going on that, and some of the drawbacks, like the power is not efficiently transferred from primary winding to secondary winding, which is based on the mutual induction process only. That's why the still research part is going on, because that's efficient power is very much low. It's a 40 to 45%. So we will see the most scenario part, that we are seeing that level 1 or level 2 or level 3 chargings. So this was the charging part, where in the normal AC charging means a single plug. We can you will also get, when you are going to buy a electric vehicle, will also get the onboard chargers for your home itself, which is level 1 category, and simultaneously you will see that some charging station point at your surrounding, which is level 2 also, which we are providing a AC power supply to the car, and which will providing a 230, and level 1 is providing a 130 volts, and it will take a too much time, like it will take a 3 hours to 4 hours to charge your half of the battery, where level 2 will take a 3 to 4 hours to charge your full of the battery, where fast charger will take a minimum 1 hour and 1 hour 20 minutes to charge your whole the battery system, or it will that's why it's called a fast charger. But again, the drawback in fast charger, that it will decrease, or it can decrease the lifespan of your battery. So whatever, if you are preferring, level 2 is the best one, because it will take a too much time, where it can the period of time, like you are investing 10 to 20 lakhs in one of car, and it will not support after 3 to 4 years. If you go towards the maintenance part, that is not a good part. So for that, we have to prefer the level 2 charger, or simultaneously you can move toward the fast charging facilities also. But as per your requirement, if you have a time, I suggest preferably to go with the level 2 chargers. So in the fast charging support, you can see that the 2 codes are there in the vehicles itself, part of the vehicles, where the upper part is only for the AC power supply, where the second part was for the DC power supply. At a plug-in point in all the vehicles, these points are given to the cars, but at the time of, depend upon the charging station or from the backend power supplies given, according to that only you can connect the ports to your vehicle, and your vehicles go easily fast, support the charging, and fast started the charging part. So this is from my side, and we have discussed about the EV motors and mathematical configurations. Along with that, reluctance motors are using nowadays with which having some major drawbacks in the configuration part, or air gaps are still there present on that. So according to that, we have to move on, and like that, if you have any questions, you can ask it.
Anyone having doubts, they can ask.
So what is the difference between peak torque and continuous torque in the motors?
Sir, peak torques define at the higher acceleration level of the motor, where continuous torque is a necessary torque where we will identify it under the damp condition or for the rigid pathway, what was the basic torque or what was the requirement from that motor we are getting from the continuously torque.
Or suppose if we are on a flyover of 15-degree grade and at the start only for particular seconds, it's a peak torque, okay? So if it converts to the continuous torque, whether the vehicle will be able to negotiate that grade, in this case, in this scenario, how to design the motor actually for particular applications? So we'll need to consider the peak torque, or the best option is to consider the continuous torque and then design the motor for any application?
Sir, we have to consider the peak torque, sir.
Oh yeah, but peak torque has some limitations, right? For 5 seconds or 10 seconds. So I think then this is because of the component limitations, or it is the characteristics of the electric motor?
Sir, basically it's depend upon the characteristic of the motor only, but somehow the back-end power supply, which of the motor you have chosen, which is delivered like a BLDC motor, we are having a controller. So without the controller power regulations, we can't deliver, like we can't go the maximum high speed. We are having a minimum speed of 40 to 50 speed only from the hub motor only. Like that, for the four-wheeler also, we are always looking for the peak torque, but the peak torque is for a limited time only. But according to the peak torque also, we have to choose the motor. That in some of cases or some interval type like a hill climbing or a higher slope of acceleration, we have to choose that motor. And according to the mechanical part also.
Okay. Any relation into between this, the peak torque and continuous torque? For example, if peak torque is the 100 Newton meter, then what should be the continuous torque?
Sir, it actually based on the numerical calculation base, sir. I'm not exactly I'm getting, but it's a numerical base, sir.
No worries. Thank you. Thank you very much.
Okay, sir.
Sir, I have a question.
Yes.
Are DC series motor used in any type of electric vehicle?
RDC, reluctance. It's a type of reluctance motor.
DC series, do they find their application in electric vehicles?
No, I have, maybe it's a research part is going on it, but I haven't yet seen the RDC series motor, like a reluctance part of motor in the practical life. Because before the permanent magnet synchronous motor, we are preferring the reluctance motor, which is having an air gap and which is covered by the IPM motor, IPM synchronous reluctance motor.
Okay, thank you, sir.
Good evening, sir. I have doubt.
Yeah.
Sir, what are the scope of switch reluctance motor in
basically, switch reluctance motor having some of the drawbacks which are covered by the IPM motor. IPM motor, like where the air gaps are present in the reluctance motor at the rotor part. So at the salient port part, the magnets are placed on that, which are called the internal permanent magnet of synchronous reluctance motor. That's why we are preferring the scenario of internal reluctance part also, but the configuration part and the manufacturing part is too much complex as compared to permanent synchronous motor. That's why we are preferring permanent synchronous motor for the nowadays in automation industries.
Okay.
Hello, sir. I have also a question. Sir, side lane charging is a future of charging method.
Side lane, yes.
Feasible or not?
Basically, in India, it is not available nowadays. Research part is going on still that in some of the countries like Norway, Netherlands, which are having a dynamic charging, dynamic wireless charging, where the side lane was providing for the wireless charging, and at the time of while you're traveling only, the battery was still charging in charging period, but the efficiency is very low, or the power losses were very much high. That's why we are not preferring, and the research part is still pending on it.
Okay, sir.
Hello.
Yes.
Sir, I have also one question related to the air gap between the stator and the rotor for BLDC motor, and how it affects the efficiency of a motor and the torque of the motor, and what is the optimized air gap?
Optimize air gap in BLDC motor.
Yes, sir. In BLDC motor, how we define the air gap in stator and the rotor part? Basically, in a hub motor.
Basically, in a hub motor is the air gap between stator and rotor part should be, it's always flow in the form of radial axial flow. So the gap between them is according to the magnetic flux create around the electromagnets cast iron, and the air gap between them are minimum 1.2 mm or 1 mm or 2 mm is there.
So there is any mathematical calculation for define
there is a mathematical calculation which will prove your theory that whatever the air gap you have taken is providing you correct efficiency power, or the flux flow through this is a calculation part, but there is a calculation.
Can it affect the torque and efficiency?
It's affect the torque.
And
yes,
the motor
it affect the torque, because it according to the torquefaction, its effect on the speed of the motor also.
So there is any mathematical model available in Google or any type of the paper how to define the air gap between the stator and the rotor for the maximum efficiency and the torque?
I have read somewhere in the someone's research patent part. So I don't I'm not getting that in this website, or just go to that site and you will identify that. I read somewhere in the research part or someone patent of that. So what was the air gap in the motors, and according to that. So it will available.
Google.
It is available some in part of the Google also.
Okay. Thank you, sir.
Okay. So I'm going to wrap this session. If anyone having any questions, or other, I will move ahead.
Sir, I have a question.
Yes.
Sir, level 1 charging and level 2 charging, do we have a variable charging rate for electric vehicle?
Basically, level 1 charging and level 2 chargings are low voltage type of chargers. Like in level 2, we are having a minimum of single phase supply, like a 230 volt or 240 volts only. Or in the other hand, we will move towards the level 1. We are having a minimum of 120, 130 is an average, which is in theoretical base. But there is always in a tolerance in practical scenario also. So whenever you will use that in your home site, like onboard chargers, which was given by the company at a time of purchasing your car, as per the power is delivering your home. Like when as a theoretically, we will say that 220 volts are coming in your home. But when you are going to check your appliances, sometimes it will getting a 215 volt, 210 volt. According to that power, you will get one average output. It will take this much time to charge that vehicle.
Sir, my question was that can we control the current or power output throughout the charging process, so we can save the energy or something like that?
Throughout process, basically, you can't control the current part, where driver circuits are already installed on the onboard charger or charging station itself. After that, when we are going to the vehicle dynamics or vehicle powertrain configuration part, where BMS are also present to cut off the power supply. If you are just put your vehicle with a charging station for a 5 or 6 hour or 7 hour. Then also, if the vehicle is fully charged, it automatically disconnect from the end of your vehicle also, because the battery pack itself having a BMS controller, which was simultaneously monitoring the charging, whatever the charge is required for the battery is fulfilled by the charging station, then it simultaneously cut off the power supply. According to that, smart BMS algorithms are designed nowadays.
Sir, one more question is that can we use level 1 and level 2 charging at a time, or a vehicle can switch on like level 1 charging at a time and again it will switch to level 2 charging?
No, it is not. It's not possible, because somehow the charging code pin is same at a time. Like if you are preferring for, like I've shown you the picture where they are having a 2 codes. One is for the AC power source and second one was for the DC power source. Where if you are want to charge the DC fast charging, you have to change.
Sir,
you can.
That, level 3 is DC, as you told earlier. Level 3.
Yes. I'm coming to that point only. Like that DC for to triggering or to turn on that system that we are coming to take the fast charging, you have to just go through hand brake. You have to apply the hand brake. So when you are going to apply the hand brake also, that it will respond that I will getting a fast charging system. So connect the connection as per that, and we are getting the power supply. So at the same time, you are not giving a power supply directly as a level 1 also or level 2 to the vehicle also, because it coming from the one entering point is one point only, the input power source for the electric vehicle.
Sir, I have one question.
Yes.
Regarding the BLDC motor and permanent magnet synchronous motor.
Yes.
Recently, Ola launched hub motor scooter.
Yes.
And earlier it used the center motor. And the center motor is the kind of the permanent magnet synchronous motor or BLDC motor.
The center motor is type of the BLDC motor. We directly can't prefer the basically in all the vehicles nowadays you will see the hub mounted motor only, or the center motor is type of BLDC center motor, which we are preferring for the 3-wheeler only. But the efficient power and the costing is going too high, so now they are coming toward the hub motor, which will also provide a space in the back end of the 2-wheeler and also balance the provide a balance to the vehicle also. So we are providing a motor direct to the wheel.
So in center motor, the stator is the stationary part and the rotor is have the permanent
stator is having electromagnets in it, which are basically when you are providing power supply, it become a magnets. Where in the rotor we are having, in the slots we are having a permanent magnets.
Then what is the difference? Basically the difference in the BLDC and the permanent magnet synchronous motor, the power source of power supply.
Source of power supply, and one of the basic difference that is it's a response basis on the Hall effect sensor. If we provide a power supply from the controller also, or while you working, or if the motor is still start, and if you disconnect the Hall effect sensor wire connection, the motor will get stopped, because it work on the response basis. That's why I categorize them in the special purpose of the motors.
So the basic difference in the BLDC and the permanent is the power source. If we supply the AC supply,
power source,
and the frequency can change, the magnetic change.
Yes. Power source and the initial starting torque and the response basis also. These are the 3 main points.
In permanent magnet synchronous motor, we supply the AC power and the frequency change and the magnetic flux change and the torque change.
Frequency never change.
Start rotate.
Frequency never change.
And BLDC motor, we provide the DC power supply and the whole sensor change.
Yeah. Wait. I will explain that. In BLDC motor, we are providing DC power source to the controller first. Then controller will creating a DC pulsating output which is creating a trapezoidal waveform, and that power supply is given to the BLDC motor, and that simultaneously we are providing from controller to Hall effect sensor, which will detect that which one power polarities will change according to that, which magnet have to create a north pole or south pole. That response basis, the BLDC motor is working. So the configuration and the manufacturing part is very much complex as compared to permanent synchronous motor also. But the synchronous motor we are using simultaneously like synchronous motor only. But in the synchronous motor, at the center rotor, we are providing a DC power supply for the field winding to create a rotation magnetic field and interlock. So while removing that providing power supply to the field winding, we directly place a permanent magnet in the synchronous motor. That's why we call that motor as a permanent. These all are the magnets. You can see that these are the diagonal square sides. All are the magnets which are connected in the rotor part of the permanent magnet synchronous motor, which can cover the drawback of synchronous motor. That's why we are preferring this.
But the architect of the center mode, BLDC center motor also we provide in rotor permanent magnets.
Yeah, in both of them, the magnets are placed in the rotor.
Okay.
Okay.
Sir, I want to ask something.
Yes.
Sir, are there any workshops and courses which are in which you are teaching the actually modeling on the software so that we can design the motors on those softwares?
Like we have the workshops at last. Now I'm wrap this session. At that we having workshops like MATLAB. We are using MATLAB, ANSYS, SolidWorks software, and on that you can easily see the thermal representation or what was the phasor angle dimensions to diagram that. So we will, our team will help you in this. And now I'm wrapping this session. So move ahead. I hope our team will suggest you in this.
Sure, sir. So you are having my contact details right now.
Basically, in the feedback form, you will provide your contact details.
Sure, sir. Sure, sir. Sir, because I have gone through some of the basics and I want to move further for the modeling process actually.
Yeah.
In the software.
Okay. Okay. So team, please handle the situations. I'm wrapping this session. So please help that the last one, I didn't see her name.
Amit Pushpa.
Yeah. Thanks. So
That's
team will help you. Yeah, team will help you.
Sure, sir. Thank you.
Okay, thanks for providing the learning to our learners. Okay, so hello learners, thanks for attending the webinar. I hope you all like the webinar and looking the exposure to enhance your learning and skills in the same domain, that is in EV. Okay, so do reply one question, that does this webinar improve your understanding of the topic? You can comment yes or no.
Yes, ma'am.
Yes.
Okay, nice. Thanks for your response, learners. Okay, so here I would like to introduce ISIE India products, which will help you enhance your skills. So come take a look of a small video about ISIE India courses that helps to enhance learning and gives the opportunities for the placement. Okay, have a look, learners, please.
Hello engineers, do you also want to expand your knowledge of electric vehicles and want to secure a good job in the automotive industry? Let me help you to get there with our online and offline products. ISIE India has been offering specific domain courses as per the industry demands with perks like pay after placement, no cost EMI, placement assurance, global wide certification by Automotive Skill Development Council ASDC and National Skill Development Corporation NSDC Government of India. We have range of courses in electric vehicle, computer-aided design and engineering, including postgraduate certification and executive PG program in EV, professional master certification program, specialization programs, fundamental programs, and internship in EV, CAD and CAE. Our postgraduate certification program in EV is specially designed for these students with 120 plus online learning hours, 100 plus hours of industrial projects and internship to give exposure of various computational tools for hybrid electric vehicle applications. It is a 12 months assured placement course with pay after placement, thus encouraging the learning without financial constraints. The course is globally valid, certified from NSDC Government of India. Our executive postgraduate program in EV is specially designed for the working professional who want to upskill themselves or looking for a career change in the EV industry. With 120 plus online learning hours, 20 plus hours of industrial projects. It is a 9-month assured placement course with globally valid certification from NSDC and ASDC Government of India. Our professional master certification program in EV Cadence EE is specially designed for the undergraduate students to pave their career path by providing industry relevant skills with 100 plus online learning hours, 5 plus hours of industrial projects. It is a 6-month placement assistance course with globally valid certification from NSDC Government of India. Along with the courses for skilling, reskilling and upskilling, at engineering institutes across India, we are setting up a state-of-art facility, Center of Excellence for e-mobility research and skill-based education, which is equipped with research and project-based learning-oriented experimental setups. This Center of Excellence is not only limited to educate the students, but also it will be utilized for research, innovation and product design and development. It is a combination of 6 labs including EV powertrain training and research lab, battery BMS training and research lab, EV charging and battery swapping lab, software modeling and simulation lab, innovation lab and renewable energy lab. Each lab is consist of number of customized workbenches and machineries. Few of them includes EV drivetrain experimental setup and motor testing workbench, hybrid drivetrain experimental setup with data logger, EV machine cutout section workbench, 2-wheeler, 3-wheeler, 4-wheeler training workbench, battery load capacity testing, battery BMS with CAN protocol workbench, V2G setup, on or off grid work charging station, battery swapping, autonomous vehicle training workbench, solar power generator and software solutions and many more. No matter from which branch you study, we commit to skill and assure you a success in your career. We have spread the joy on thousands of faces, becoming their partner along with the journey towards success. Join us and take advantage to unlock endless career opportunities.
Okay, thanks learners for watching this video patiently. Hope you guys have understood the products of ISIE India. So any of you wants to enroll in the course or interested in the course, kindly send us the inquiry through a QR code. Please hear carefully that those who are interested to know about EV courses or want to join the courses, only those have to scan this QR code that are displayed in the screen.
The learners, if you're interested in joining of any of the program of ISI India regarding the electric vehicles, so kindly scan our QR code. This QR code only for the course inquiry. Okay. The certificate link will be shared over the mail after 7 p.m. Okay. So if you're interested in joining any of the program of ISI India, you can scan our QR code. Thank you, learner, for joining our webinar. I hope like you guys like our webinar. And for the next webinar, the meeting link will be shared again over the Telegram channel. So for the daily updates, you can join our Telegram. The link is mentioned in the chat box. Each webinar link will be shared only on the Telegram channel. Okay. Learners, if you're interested in any of the program, please scan our QR code. Okay. Our technical counselor will connect with you within 20